Hey guys, let's go over the bisection method algorithm. So the algorithm is going to be given to you for each of these numerical methods, and this is to help you actually code up the method on the computer using MATLAB. Or you could use it for whatever language you want to use. In this class though, we will be using MATLAB. Alright, so let's talk about this, and then after this video we'll do an example, and then after that one we will look at this in MATLAB. Alright, what we're doing here is we're going to find the solution to f of x equals 0. Now, this means, since it's got to be in this form, that if your equation is not originally set equal to 0, you need to make sure you do the algebra to get it to where it is equal to 0. Okay? And this f of x is going to be a continuous function on the interval a,b, where the endpoints, when you plug them into the function, have to have opposite signs. All right. And for the algorithms, I'm going to show you the inputs you need, the outputs you'll get, and then we'll go through all of the different steps. All right. So the inputs you need, you have to have the endpoints a and b. We've got to have the tolerance. We have to have the max number of iterations. The reason why we want this is so we don't get stuck in one of those infinite loops. All right. So if you've already done 2,000 iterations, probably you've done something wrong or you can't find a root. And we don't want to just keep going indefinitely. So this will help us prevent infinite loops. And then f of x, you obviously have to have that. Now the output that you're going to get, hopefully, will be the approximate solution, x in s. And if you can't get that for whatever the reason, we will give some sort of failure message to tell the user the solution couldn't come up with an estimate. All right, so let's go over the steps. The first one is we're going to set up our counter. The counter will be used to make sure we don't go over this max number of iterations. So I'm just going to call it I here. So we're going to set I equal to 1, and then right after that, we're going to create a variable fa. Fa is just going to be our f of x when x is equal to a. Now, after you initialize those two things, let's do a while loop. While I is less than or equal to the max number of iterations, we're going to do steps 3 through 6. Step 3 is where we get our bracket and we find the midpoint. So if you remember from the last video, let's look at this. We had this bracket. The estimate of the numerical solution for each of the brackets is right in the middle. So this is the midpoint. So that's where we get the a plus b over 2. And then once we have this value, what we're going to do is we're going to plug that into the function. And I'm just going to call that fx in s. All right, now we got that. Next step, set up an if statement. This is going to check to see if we have reached our estimate. So now if you can manage to get your fx in s exactly equal to 0, that means you're done because you found the exact solution. Now usually you're not going to have that happen. So usually we're going to look at this. We'll have b minus a over 2. So if we have this, and if that is less than our tolerance, then we're going to say we're done. We're going to output the numerical solution, x in s, and then we're done. So at that point you can stop. You've already found your estimate. Now if these two things are not met, then we're going to continue on. We're going to update our counter. So I is going to equal I plus 1, and then we're going to check and see what our next bracket should be. So here you're going to do that check. You're going to see if f of a times f of x in s is greater than 0, just like we did in the last video, if y'all remember. So if you remember, we wrote this out. So that's all we're doing is this portion right here. We're just looking at the signs for each of these, multiply them together, see if it's positive or negative. Okay. So if it is positive, a gets set equal to x in s, and then our fa variable now gets set equal to f of x in s. So we're just updating the interval endpoints. Now otherwise, if this wasn't true, we're going to come down here, B gets set equal to X and S. All right. And then after you finish the while loop, if you happen to reach the max number of iterations, then you'll do step 7 and display some sort of failure message saying the method failed after so many iterations. All right, so that is the algorithm, and I will show you how to use that in MATLAB coming up in another video. All right, I will see y'all in the next one for an example.